Hi everyone, welcome to my channel. Today, we're breaking down machine learning and its essential types, supervised and unsupervised learning, and their most common tasks, like regression, classification, and clustering. This comprehensive overview will provide a solid foundation for understanding how AI systems learn and make decisions. Whether you're new to AI, prepping for interviews, or just want to understand terms like binary classification or clustering, this video has you covered. We'll demystify these concepts with clear explanations and practical examples. Let's get started on this exciting journey into machine learning. So what exactly is machine learning? Unlike traditional programming, where a developer writes explicit rules step by step for every possible scenario, machine learning is when computers improve their performance by analyzing vast amounts of data, finding intricate patterns and making accurate predictions without needing to be told every single step. It's about learning from experience, much like humans do. At the heart of it, machine learning algorithms automatically identify complex relationships and hidden trends in data sets, making them incredibly powerful tools for everything from precise medical diagnosis and drug discovery to personalized recommendations on streaming platforms and fraud detection in financial transactions. These algorithms are constantly evolving and improving. There are two main types of machine learning you'll hear about the most, forming the bedrock of nearly all AI applications: supervised learning and unsupervised learning. Understanding these two categories is crucial for grasping the broader field of machine learning. This distinction is the foundation for almost all machine learning approaches you'll see implemented in business, cutting-edge research, and even the everyday technologies you interact with. We'll explore how each type operates and the unique problems they are designed to solve. Let's walk through each type and see how they're used in real-world scenarios. First is supervised learning. This fundamental approach means training a model using meticulously labeled data, where every input example is explicitly paired with the correct answer or label. This allows the model to learn the mapping between inputs and outputs. Think of it like being given a stack of math tests, where each question already includes the correct solution. The algorithm meticulously studies these examples, learning the underlying rules and patterns, so it can then try to solve similar new questions on its own next time with high accuracy. It's learning by example. In supervised learning, there are two major and distinct tasks that models are trained to perform: regression and classification. Each addresses a different type of prediction problem, depending on the nature of the output you want to achieve. Regression is primarily about predicting continuous numerical values. For example, this could involve predicting temperatures for the next week based on historical weather data, accurately estimating real estate prices based on various property features, or forecasting volatile stock prices based on market trends and economic indicators. The output is always a number within a range. In a regression task, the algorithm's goal is to find the precise mathematical relationship between the input features and a continuous numerical output. It aims to draw a line or curve that best fits the data points, allowing it to predict values for new, unseen inputs. This is often visualized with a best fit line on a scatter plot. Classification, in contrast to regression, predicts discrete categories or labels instead of numbers. Examples include determining whether an email is spam or not spam by analyzing its content, recognizing handwritten digits from images, or diagnosing diseases from a set of patient symptoms and medical test results. The output is always a specific class. All classification tasks involve sorting data into distinct, predefined groups or classes based on the patterns and features the model has learned from the labeled training data. The model learns to assign each new input to the most appropriate category, effectively categorizing information. This process is fundamental to many decision-making systems. Classification itself has two main types, depending on the number of possible outcomes: binary classification and multi-class classification. These distinctions are important for designing the right model for your specific problem. In binary classification, the model is designed to choose between exactly two distinct classes, like yes or no, true or false, or the classic spam or not spam. It's a decision between two mutually exclusive options. This is one of the most common forms of classification. It's widely used in critical applications such as fraud detection, where a transaction is classified as either fraudulent or legitimate; medical diagnosis, determining the presence or absence of a specific disease; and even in quality control, identifying defective or non-defective products. The model makes a clear two-way decision. Multiclass classification, on the other hand, handles cases with more than two categories, allowing for a broader range of predictions. This is essential when the problem requires distinguishing among several different options. It expands the decision-making capability beyond a simple binary choice. Imagine sorting images of animals. The model might need to classify an image as a cat, dog, rabbit, or bird. The model learns to recognize the unique features of all available options, and then chooses the single most appropriate category for each new input, effectively distinguishing between multiple classes. Now let's shift to unsupervised learning. In this paradigm, there are no labels provided with the data. The model only gets raw input data, and its primary objective is to discover inherent structures, patterns, similarities, or groups within that data entirely on its own, without any prior guidance or correct answers. Think of it like being handed a large pile of mixed photos, perhaps from different events or subjects, and having to organize them into similar groups without anyone telling you what's in each photo or what the categories should be. You'd look for visual cues to create your own groupings. The algorithm does something similar, but with data points. The most common and widely used task in unsupervised learning, which exemplifies its core purpose of finding hidden structures, is clustering. Clustering algorithms are designed to identify natural groupings within datasets. Clustering means grouping similar data points together based on their intrinsic characteristics, without any prior knowledge of what those groups should be or how many groups there might be. The algorithm discovers these groupings organically from the data itself. It's about finding inherent structure. You'll see clustering used extensively to segment customers in marketing, identifying distinct customer behaviors and preferences, group products by similarity for better inventory management or recommendation systems, and discover hidden trends and anomalies in large sets of medical data, potentially leading to new insights into diseases. It's a powerful tool for exploration. Clustering helps businesses and researchers find meaningful structure and insights in vast amounts of data, even when they don't know the answers or the categories ahead of time. It's about uncovering the underlying organization of complex datasets, revealing patterns that might otherwise remain hidden. Let's recap the core concepts we've covered. Supervised learning is characterized by its use of labeled data to either predict continuous numbers, which is regression, or discrete categories, which is classification. Classification itself further breaks down into binary classification for 2 outcomes, and multi-class classification for more than 2. This approach is all about learning from examples. Conversely, unsupervised learning operates without labeled data, focusing on finding hidden patterns, structures, and relationships within the data itself, most often via clustering, where similar data points are grouped together. It's about discovery and organization without explicit guidance. These powerful machine learning approaches collectively power everything from your personalized Netflix recommendations and accurate medical diagnostics to robust fraud detection systems and groundbreaking scientific discoveries across various fields. They are integral to modern technology and research. If this detailed explanation helped you understand the fundamental types of machine learning, please hit like and subscribe for more easy-to-understand AI and data science videos. Your support helps us create more valuable content. You can also check out the free Microsoft Learn course linked below for an even deeper dive into these topics.